Okay, so we continue with the next lecture, which is about the measure of dispersion. Okay, so remember in the previous one we completed the central tendency measurements, but those measurements are somehow incomplete to define the population. We also need the dispersion. Why? Okay, let's go through the theory. The measure of central tendency gives a single value that represents the whole population, the whole value. However, central tendency cannot describe the observation fully. The measure of dispersion helps us to study the variability of the items. With dispersion, we measure the variation of the items among themselves, and we measure the variation around the average. What does it mean? It means that, yes, we can have a central tendency measurement to represent the population. For example, the population of a student at NAST has a mean value of the age of 23. But how is this population? Is it is it homogeneous in terms of all the students have more or less the same age, or is it heterogeneous, meaning that we have very old and very young students? I mean, we need this measure to basically complete the information about the population. And there are many applications. For example, in terms of measurement equipment, LiDAR or a GPS, we can have maybe 100 measurements of a single point, and the mean can be the actual center. Yeah. But in a good GPS, the different measurements will be very different, very dispersed, always around the mean, yes, but very dispersed. In a good GPS, for example, the example in the right side, we have all the measurements, all the fixed GPS close to the mean. That means the good GPS on the right side is more reliable. This is what we mean by the accuracy of the GPS. Yeah. Or if we are talking about other studies like environmental studies, like soil carbon, and we need to complete the measure of central tendency with dispersion to basically describe better the population. Which are the different measurements we are going to cover? At least four: the range, the quartiles, and the variance and the standard deviation. The range is the simplest one. It's basically the difference between the maximum and the minimum value. Okay, but it's very useful. In a class, we have the oldest person and the youngest person. For example, in our class, if we count myself, the lecturer, I assume normally I'm the oldest, but not always. But let's imagine I'm the oldest. So I'm 37, and the youngest is maybe, I don't know, let's say Natange, who is, I don't know, 22, 23, 22. So what is the range? 37 minus 22, 15 years old. Okay? So we have one example here to calculate this range. So what is the maximum among these numbers? 12, 5, 10, 7, 12, 1, 18, 7, 8, 7, 18. What is the minimum? 5. 18 minus 5, 13. This is the range. Okay, the quartiles. Quartiles is basically the same concept as the range, but where we eliminate the outliers. So it's the difference between the upper quartile and the lower quartile. This is the quartile deviation. And this is called the interquartile range. So as I said, it's like the range, but we eliminate the extremes. Quartiles are the values that divide the list of numbers into quarters. So if we have 10 numbers, first we need to sort them from the minimum to the maximum. What is the value in the middle? Remember, the median, yeah? So if we take the median, we take 50% larger than the median and 50% smaller than the median. So if we divide the upper group and the lower group, or the upper block and the lower block into two again, so these are the quartiles. The first quartile is the first 25%, the third quartile is the first 75%, and the second quartile is the median. Okay, so again, 25. If we cut the rest, the subtraction or the group of data between the quartile 1 and the quartile 3 encompasses 50% of all the data. So it's the 50% which is not influenced by extreme values. Okay, so as an exercise, calculate the quartile 1 and quartile 2, or sorry, 3, not 2, 3. Yeah. So, as I said, we will repeat this in the exercise. But as a practical now, sorry, there is a mistake here. Calculate the quartile 1, quartile 3, and the difference. Okay. The variance. The objective of the variance is to measure is a measure of data clustering around the mean. Okay, so how far the different values of our sample of our population are around the mean. So the formula is the sum of the squares of the difference between any value and the mean for the whole population or the whole sample, divided by the number of elements minus 1. What are we calculating here? Is the mean of a sample or the mean of a population? Remember the notation, S and X hat is a sample, yeah? The issue with the variance is the units of the measurements. If the data is in minutes, the unit will be a minute squared, yeah? Because of the square in the formula. But we'll deal with this later. Now, just keep in mind how to calculate it. Learn how to calculate a variance. The formula is what matters here. Yeah. What is the standard deviation? The standard deviation is basically the square root of the variance. Okay. Now the answer will have the same units as the measurement. So the standard deviation is in the same units as the input data. So if we want to calculate the standard deviation of the distance which is measured by a specific device, the standard deviation is also in meters. So if the inputs are in meters, the standard deviation is also in meters. Okay. Okay. So let me stop here this audio, and then we continue with a very interesting issue, which is the comparison between the variance and the standard deviation.